Welcome to another Founder Wisdom Pod. We have Keiland Cooper with us. He's a neuroscientist and AI researcher, currently a neuroscience research associate at the Center for Neurobiology and Learning and Memory at UC Irvine. And he's the VP at Continual AI. He was the co-founder of that company back in 2018. We're going to talk about AI, neuroscience, everything between. This podcast is brought to you by podpire.com. That's my podcasting company if you want to start your scale pod. And this supplement here for the brain, this nootropics called Qualia. It's pretty amazing if you want to optimize mental performances as an entrepreneur on a daily basis. Keiland, I'm glad to have you on. Tell me a bit more about yourself, your background, and what you're up to.
Hi, yes. So thanks for having me on and looking forward to talking a bit about neuroscience and AI with some of your listeners. Um, so you pretty much covered it. The core of my work is pure neuroscience research at UC Irvine, that's in California. And so I think I have the best job in the world because I get to go into the lab and just play around with ideas all day long. And some of them fail, some of them you've got some problems to solve, but every now and then you have some good ones that work and you can really learn something deep about not just how the brain works, but where our brains. So how do we work as people? And I'm also very interested in artificial intelligence, which nowadays everyone is interested in artificial intelligence. And so I've done some research on that, and we have a nonprofit called Continual AI that you brought up that really tries to help support the field in any way that we can. So yeah, happy to keep chatting.
What kind of experiments are you playing around with nowadays?
So nowadays I'm doing a lot of things in a bunch of different directions. We have stuff with people, stuff with animals, stuff with just pure computers. It seems like with the main focus of my work is on learning and memory. So how is it that we all started out as a baby at one point? We couldn't do very many things, but at some point we all become pretty smart and bright, educated people that can do whatever it is, that skill that you bring to the table. So how do you go from not knowing much of anything to being among the best in the world? What does that process of learning and memory take? I call that continual learning. We look at that in biology. We also look at that in AI, because ultimately that's what we want out of our artificial intelligence systems, right? And it also applies to diseases, particularly diseases of memory, such as Alzheimer's, which most people know about. But particularly the types of questions that we ask also impact diseases like addiction or schizophrenia, or even just normal aging that we all go through as our memories start to decline. So this core fundamental research on learning and memory really touches on a really wide variety of human experience. And to me, that's what makes it so interesting, because no matter where you look, it's just kind of there.
Right. And the learning stuff, I guess we are all born on this planet Earth with this survival instinct and this evolutionary drive that is a question in itself. But then it seems that it's reward and punishment sort of systems, probably a bit more complex than that. But when I get endorphins and serotonins in my brain, I'm driven to do one thing that's mostly aligned with the laws of evolution, aka reproduce, eat, get better. I guess humans learn to learn because this was a competitive advantage against other species. Still a wonder of nature that this exists. And from these neuro slash biochemicals that are released in our brain, I guess some pathway solidifies or get better than others because we've learned that these are the way to go. So is that a way you would describe learning on your side as well?
Yeah, you bring up a really good point, actually, which is when you think of evolution and the basic premise of how evolution works, which is you reproduce, you pass your genes on. Every now and then some of your genes change a little bit, and some of those changes are beneficial, so those changes stick. If they're not beneficial, they don't stick. evolution is a very slow process, right? It's somewhat random depending on how you're looking at it. And it takes, depending on the species, hand waving away all the very specific details, it takes a really long time, on the order of years to decades to some species millennia. In my mind, the biggest advantage of why learning and memory specifically were so useful is that now you're no longer chained to your genes. Now, if you're an animal and you get past a new genetic adaptation that you could only get through evolution, now you can learn without having to rely on those genetic adaptations to be passed to you. Case in point, if you're an animal that adapted to climb in some sort of tree and your genes made you able to climb in that tree, if you're able to learn and adapt within your own lifespan, now you can, if that tree gets cut down, you can maybe learn and adapt to try some other food or try some other thing. And humans, we just kind of turn the dial up to 11 on that, where we can learn drastically more complex things than most other animals. And we have a lot of neural circuitry to support that. And yes, a lot of that was evolutionarily given, but the premise still holds that we can adapt despite our genes, not just based on what we have. So learning kind of gives us that advantage that we couldn't have otherwise.
Right. And when it comes to artificial intelligence, it seems that its learning processes is a tad different, and how it quote unquote synthesizes information, how it resonates. Um, it was somewhat built on the brain, the way these algorithms work, but do you think it can really scale that way? And do you think we have to mimic the human brain to really make a general artificial intelligence?
That is a perfect question, if not the question, I think, when it comes to artificial intelligence. The way that I see it, and I've said this for a while now, if you kind of ignore the recent bump in really good marketing for artificial intelligence, and some of it's well deserved because of the advancements in artificial intelligence. Neuroscience and artificial intelligence have kind of grown up together. They're both relatively young fields, depending on how you slice it. And each one seems to kind of propel the other forward. I call it a neuroscience AI feedback loop, because as you learn more about the brain, you have more, even if it's not direct implementations of how the brain works, at least you're inspired by how the brain works, and that makes AI better. And then as AI gets better, not only do you have a model now that you can reason with and ask questions to, in the case of our lab even, we're using deep learning to decode neural activity. So if we didn't have a convolutional neural network or an autoencoder or these sorts of things, some of the insights that we get from the brain, we wouldn't have otherwise. So each one, even back in the 50s, 60s, 70s, 80s, when you know, the really big founders who named the fields started really thinking more deeply and computationally about these problems, neuroscience and AI have always been hand in hand. And I'd even go so far to say it's even beyond AI, it's even computation. So Alan Turing, the guy who, the godfather of computing, he was very interested in not building a computer, but building a brain. From the onset of that, he just wanted to build a thinking machine, and he didn't care what that machine was. It just so happened it was very useful to, have spreadsheets, make emails, run data centers, and prop up the US and global economy. But the goal has always kind of been there. We want to make a machine that's as smart, if not smarter, than we are. And that's never really left. Towards your second question of, do we need to imitate the brain to have AI? I think we have enough evidence that the answer is no. But evolution, like you were saying, has been tinkering with thinking machines for way longer than we have. So to say that there aren't principles that we can derive from the brain, that we could add to AI, and people have certainly done this, and we do see that there is something to that, even if it's not a one-for-one exact model of how the brain works, but these broad strokes of how the brain works, and we add those to computation, we certainly think it's helpful. But at one point, search was considered AI, and Google search works very different than how the brain works. But nowadays, we just think of that as an algorithm. We don't think of that as AI. And so 20 years from now, whatever we think of AI is probably going to look pretty different than what we have now.
What is your definition of AGI?
AGI, artificial general intelligence. I think so like I said, AI is this funny field where it's just whatever we can't do yet seems to kind of be what we end up defining it as. At one point it was, oh, if we can play chess, we'll have AGI, and then we played chess. We're like, this is nothing like what we want. Nowadays we have ChatGPT, but it's pretty dang impressive, but nevertheless, it doesn't feel like AGI quite yet. And so my hand waving answer is certainly beyond the Turing test, and more along the lines of anything a human can do, it can do better. Anything. And I think that's kind of implicitly what we mean. But if you want to actually sit down and define that, it's hard, because I think part of the reason that AI is so interesting, especially when you couple it with neuroscience, is it kind of is an exploration of what it means to be human, right? At one point, we thought intelligence just meant if you could play chess, you're smart. If you can beat Jeopardy, you're smart. If you can play Go, you're smart. If you can fold proteins, you're smart. And yes, there's some fragment of intelligence there. But all of these really smart systems can't walk and chew gum at the same time. They can't look at, ChatGPT can't look at a person's expressions and tell you that they're happy or sad. So I think there's a lot of little things in there that we kind of overlook, and forget that even some of the basic things that a toddler can do, a human toddler, we are decades away from having a robot or an AI or a machine emulate them.
ChatGPT sometimes feel to me like an AGI, and arguably it does things better than most humans. Um, I think, my definition of AGI would be when it starts to be creative and we totally lose control from there because we just don't understand what it's saying or why it's saying. I think it would be nice enough to explain us where it's going with that, but strange stuff starts happening, and magic starts happening. I think that would be my definition. What does it take for an AI to be quote unquote creative and innovative and push the boundary further?
Well, I mean, that's a question. You could ask ChatGPT to write you a poem, and you wouldn't think that that's an act of creation. You could have it ask you to write you a song. You could have it nowadays, now that their multimodal models are being deployed, you can have it draw you a picture. You can have some OpenAI. I don't think ChatGPT can do this yet, but Sora can make videos. The generative and generative AI is a placeholder for creative AI. You're generating new content. So I guess my question is what is and isn't creative about that process?
Right, because 1 + 1 = 2 isn't really creative, and yeah, like it's full of value nowadays because you could upload stuff onto it and say like with Ernest Hemingway's voice, just write something about this actual topic, and that will be new. No one will ever have done that before. I guess, yeah, when I'm thinking about creativity, is like major inventions, light, Wi-Fi, 5G, like stuff that is of major value to humans But what if it creates stuff that is valuable for itself? I mean, it wouldn't be programmed in its paradigm to do so, but guess what I'm saying is probably like breakthrough, and it's the bias here is like the value that will be created to humans, like understanding laws of physics, for example, which would need a lot of hardware, I guess. Um, yeah, because
Yeah,
creativity, I guess
I
that's
see.
the value
Yeah.
of it. It's like low level creativity and decent creativity and groundbreaking creativity.
Yeah. And that's what I'm saying. I think that kind of unpacking of it is again what makes from a research standpoint and from a psychological or neuroscientific standpoint, why AI is just so terribly interesting. It really needs to be more interesting to researchers from that point of view, rather than just what can it do, because um, some of these really deep philosophical questions that we've been wrestling around as a species with for hundreds of thousands of years in some cases, or now we have a test bed to really kind of play with them. Because I would say in some aspects, ChatGPT and many other, ChatGPT is the one everyone knows now because it's shipping. But in the research context, we've had generative AI for a long time. Um, and when it comes to value, I don't know, that's a question. So like AlphaFold, DeepMind's kind of really big deal. It's effectively a generative AI. And it can do in 10 seconds what would take a researcher a year, which can fold a protein. Usually that would be a lot of lab hours to just get one structure. And there's thousands of proteins out there that we now have some idea of a structure for. And with that structure, you can make a vaccine. They were folding proteins for COVID. In that particular case, we didn't need it for COVID, but it was there and we could ask questions. And you bet pharmaceutical companies are all using these algorithms now, and probably beyond the ones that are published on a few years ago. When it comes to physics, there's generative AI for deriving equations. So just like a researcher, say you're an astronomer and you collect your data about how planets orbit around a star in some other planetary system, whatever, you can take that data, feed it into an AI, and it'll generate to you the equation that governs that system. And you can do that for pendulums. You can do that for smaller body systems, and the equations that it spits out are the exact same ones that people and really smart, famous physicists had derived themselves. So I still think it makes it interesting because it's not just the product anymore. That because you look at that and you say, well, obviously it does that. That's what we built it to do. It spits out what we asked it to spit out. But is that creative? And so it kind of kicks the can from the product more to what I think you might mean, which is the agency of the system. That it's not like ChatGPT was just sitting there on a server at Google and thought, you know what would be beautiful? This piece of artwork. I'm going to send it to you without you knowing, or I'm going to without being prompted, without being told what to do, I'm just going to draw this artwork and send it to Christie's auction house and see if anybody buys it. But generative AI has sold for quite a bit of money in the art auction houses now. At one point, a lot of AI generated art was being sold for crypto. So real money is being put behind things that humans didn't make themselves, which kind of really opens up and expands some of these very human endeavors that we once thought were just us.
Do you feel that for software and AI to advance, you also need hardware to advance at similar, if not higher rate?
It's a really good question. I think the current architectures, so particularly deep learning and the so what made ChatGPT really possible was that we transitioned from a standard neural network architecture that we'd been using for a while to one called the transformer architecture. And yes, the transformer architecture, there's a lot of advantages, but the biggest advantage to it is that it's way easier to train. If it's easier to train, that means there's a lot less man hours just waiting for GPUs to spin. There's a lot less money on the company side. And if you train these things with the thought that the more data you feed it, the smarter it will be, you're just asking yourself for really long training cycles and really long periods of time for these things to push forward. That said, well, so the summary of that part is if we use the same architectures, the way things have been going, it seems like we need the better the hardware, the faster they train, because now you can have more data and then it's better. I don't think there's any reason to believe that that's the only architecture that could produce the same results, at least that we see now. Maybe some of the other things that we expect of AI that we haven't had yet, maybe it does require something new, who knows? But I think because the current approach worked well and it was easy and there didn't need to be enough thought, it was just, well, if it works, let's just keep pushing the boundaries and making it work, rather than let's make it work, but also take into account, can we have ChatGPT run on a laptop? Which I guess nowadays the trained answer is yes, you can have a trained ChatGPT run on your laptop, or some analog llama or Gemma or whatever. But take it back to neuroscience. The brain runs on the same amount of electricity as a light bulb, and all you have to do is feed it some sugar. So we have at least an N of one of a very smart, complex system that doesn't require a data center in 5 countries. And so we know it's possible, but it's making that jump from, is it an architectural thing? Could you run on one NVIDIA GPU a human brain? Who knows? Do you need a data center to do that? Who knows? I don't think we do. I just think we haven't really prioritized the efficiency thing as much as let's just make it work at whatever means possible.
You feel that an AI assistant could help you in the lab? Let's say that it's filming your experiments, understanding what's going on. Do you feel some kind of Jarvis would be useful for you on a daily basis?
Yeah, so when I was an undergrad and first was learning how to code, I tried to build my own little Jarvis, and I could, like, it had voice commands, super rudimentary. There wasn't much of the deep learning stuff that we had now then. So, I could be like, open YouTube, and it would open YouTube, and I could be like, send an email, and it would send an email. I think I'm certainly benefiting. Well, like I said, we get a lot of neural data, like terabytes worth of data from the brain, and we have to make sense of that. So I do use deep learning, in addition to some more standard approaches, statistical approaches, mathematical approaches, to actually make sense of neural data. So I'm already getting assisted from deep learning. But as a lab assistant, I don't know. I use it, I think of it now more as like a tool that performs better than other tools, but it's not, I have undergrads that work for me in the lab that can do more than most AI tools can. So I haven't outsourced human help quite yet for this kind of stuff.
When are we due to see the comings of Neuralink, and what would that mean for society?
Well, it depends on whose sales pitch you're waiting for. If you're waiting for the Elon Musk sales pitch of I'm going to put music in your brain, you're going to probably be waiting a while for that. But if you want to have a person who suffered an accident and couldn't move their arms or legs, use a robotic arm or a computer, people have been doing that for 10 years. We've been doing that way before Neuralink came along. Neuralink made it sleek and made it, I think, made it more of a consumable medical product, if that makes any sense. It's sleeker, and there's a lot of interesting tech to make brain computer interfaces a lot more usable. The robotics stuff for surgery, if it pans out, will actually be pretty cool just because it's really hard to put a lot of wires in the brain. It's like terribly difficult to do that. So if that stuff pans out, I think it would have something there. But Neuralink isn't the only company, and people have been walking around with chips in their brain for 2 decades. We just call them cochlear implants and don't really think of them as this cool sci-fi brain recording technique. But there's thousands of people walking around with Parkinson's implants in their brain. And I think now there's clinical trials for obesity or depression or some other ailments. And they're very rudimentary devices, but nevertheless, you can get the same ailment of the same prevention or treatment of symptoms as some drugs, like pharmaceutical drugs that people were taking prior. So we've already done it. It's just, can we scale it up? And then the question of, can we go from these already proven BCI devices to ones that are more sci-fi, more cognitive? Like, can I put my phone in my brain? Can I Google stuff just by thinking about it? Can I hack my eye or visual cortex and see a screen just sitting there? That stuff is a little bit farther out. And mainly it's, in some cases, it's a hardware problem where it's hard to put wires in the brain, but more so we don't understand how the brain works yet. We don't even know how to do that complex stuff. So that's where we got to go out of the pharma and out of the companies and back to the labs to actually understand the principles of these systems.
Thanks for your time, Keiland. Where can people find out more about you?
Yes, so I'm sometimes on Twitter, not as much as I used to be. I have a website, kwcooper.xyz or keiland.com or keiland.co, in my email. But I have a pretty unique name, so just Google me. I'm sure you'll find it.